Hello boys and girls, here we have section 8.3 Scientific Notation Part B. In this part, we will learn some applications of scientific notation. Scientific notation actually help us in the calculations when we need some very large or small numbers. Let's study a few examples. Example 5. Here you have to find the values of the expressions and express your answer in scientific notations. For part A, both numbers are in scientific notations, but you find that the index, the powers of 10 are not the same, so we have to do some more things before we can do the calculation without using the calculator. Here, for the first one, 1.6 times 10 to the power of 8, we can rewrite as 10 to the power of 1 times 10 to the power of 7 plus 7 times 10 to the power of 7. For this case, we rewrite 10 to the power of 8 into 10 to the power of 1 plus 7. That means 10 to the power of 1 times 10 to the power of 7. So here we have the common factor 10 to the power of 7, and we can take out, and we got 1.6 times 10. That means 16 times 10 to the power of 7. And we take out the common factor 10 to the power of 7 and got 16 plus 7 times 10 to the power of 7. And this is 23 times 10 to the power of 7. But pay attention, this is not the answer because it is not in scientific notations. So we have to do one more step. For 223, this is 2.3 times 10. So finally, you have 2.3 times 10 to the power of 1 plus 7. And the answer is 2.3 times 10 to the power of 8. Part B. Here, we have both of them written in scientific notation in these subtractions. But the index of 10 are not the same. Similarly, we can try to use the index law to rewrite the expressions to help the calculations. First, for 3.4 times 10 to the power of -5, we just copy. And then for 10 to the power of -6, we rewrite as 10 to the power of -5 plus -1. So you can rewrite as 8.1 times 10 to the power of -5 times 10 to the power of -1. Then we have the common factor 10 to the power of -5. So we have 3.4 times 10 to the power of -5 minus, this is 0.81 times 10 to the power of -5. Take out the common factor. We get the following. Sorry, this is -5. So we have the answer 2.59 times 10 to the power of -5. This is line between 1 to 10, so this is the final answer. For part C, the numbers are very small, and before you do the calculation, you can firstly rewrite them in scientific notation. The first one, this is 1.5, and the decimal point is moved 1, 2, 3, 4, 5, 6, 7, 8. X to the right. So this is 10 to the power of negative 8 times here. The decimal points we move 1, 2, 3, 4, 5. 5 decimal place to the right. So this is 6 times 10 to the power of negative 5. And for the values, 1.5 times 6, you got 9. And then for the 10 powers, we have 10 to the power of negative 8 plus negative 5. So finally, you have 9 times 10 to the power of negative 15. Part B. Here we have two very large numbers, so we try to rewrite them in scientific notation first. For the first one, you move the decimal place 5 places to the left. So this is 3.1 times 10 to the power of 5. And this is divided by the second number. The decimal place, you move 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 places to the left. So this is 1.24 times 10 to the power of 9. And we try to rewrite into fractions. Then we have 3.1 over 1.24. You get 2.5. And for 10 to the power of 5 is divided by 10 to the power of 9. You have 10 to the power of 5 minus 9. So finally, this is 2.5 times 10 to the power of negative 4. Actually, we can use the calculator to help to input some number with many zeros. And you have a key in your calculator, EXP, which means exponent index. So if you want to input like 3.5 times 10 to the power of 11, you just press 3.5 exponent 11. If you want to input x times 10 to the power of 10, you just press 8 exponent 10. And similarly, if we have some very small number like this one, this is equal to 1.4 times 10 to the power of negative 10. So when you use your calculator, you just press 1.4 exponent negative 10. Then you can input the values of this number in scientific notations. You can try to do yourself. Example 6. Suppose there are 30 days in a month. How many seconds are there in this month? You have to express your answer in scientific notations and round the answer off to 2 SIV figures. Now, let's try to find the number of seconds in this month. We have 30 days, and for each day there are 24 hours. And for each hour there are 60 minutes. And for each minute there are 60 seconds. So finally, pressing your calculator, you find that there are 2592000 seconds. And we write in scientific notations. We move the decimal point 6 places to the left, so this is 2.592 times 10 to the power of 6 seconds. And finally, you have to round off to 2 SI figures. So the two most significant figures are 2 and 5 in this case. So we have the answer. This is 2.9 plus 1. So round off is 2.6 times 10 to the power 6 seconds. And this is correct to 2 SIG figure. The last example, it is a question from exercise 8C, question 32. Part A, you have to express the following 4 numbers in scientific notation. For each of them, they are not in the correct form. Then let's try. For the first number, you will write 250 into 2.5 times 10 squared. So this is 2.5 times 10 to the power of 2 plus negative 11. This is negative 9. Second, for 0.06, this is 6 times 10 to the power of negative 2 times 10 to the power of negative 7. So this is 10 to the power of negative 2 plus negative 7. This is negative 9. Third, 13 times 10 to the power of negative 10. For 13, this is 1.3 times 1 to the power of 1. So this is 1.3 times 10 to the power of 1 plus negative 10. So this is negative 9. The last one, 754 times 10 to the power of negative 12. For 754, this is 7.54 times 10 squared. So similarly, which is equal to 7.54 times 10 to the power of 2 plus negative 12. This is negative 10. Part B, you have to arrange numbers in descending order. 大字細. So try to look at the numbers in scientific notations. They are all expressed in 10 to the power of a negative number. So we just have to compare the index. If it is more negative, then that means this is a smaller number. So these 3 are greater. Then we go ahead to compare the first 3 numbers. They have the same powers of 10, so we just need to compare the values 2.5, 6, and 1.3. And this is the greatest, and this is the second one, and this is the third one, and this is the last one. So for part B, we can just write because 6 times 10 to the power of negative 9 is greater than 2.5 times 10 to the power of negative 9, which is greater than 1.3 times 10 to the power of negative 9. And finally, they are all greater than 7.54 times 10 to the power of negative 10. So we have the following conclusions. 0.06 times 10 to the power of negative 7 is greater than 250 times 10 to the power of negative 1 is which is greater than 13 times 10 to the power of negative 10. And finally, this is greater than 754 times 10 to the power of negative 12. Now it's your turn. This is the end of section Exponents 3. Please finish the exercise and assignment in lesson Exponents 3B. Pay attention that for some cases you are not allowed to use the calculator, but for some questions you have to use the calculator and practice on using the button EXP.